Assalamualaikum to Dr. Ida. I hope you're in the pink of health. Today, our group will be presenting about a deep foundation for both the complete project and the ongoing project. For the complete project, we decided to do or to use a Merdeka 118. Meanwhile, for the ongoing project, we decided to use Bukit Tugu Bridge that is located in Kelantan. Okay, before we begin any further, let me first introduce our group members. For our first group member is called Muhammad Faris bin Hisham. Our second group member is Muhammad Ifan Uzai bin Abani Uzai. Our third group member is Muhammad Faris Ifan bin Mat Yuso. And last but not least, myself, Muhammad Syami Syabuddin bin Azizi. Okay, without further ado, let us move on to the project background of the complete building first. Okay, for this one, we are not choosing Merdeka 118. For the project overview, it was located in Kuala Lumpur, Malaysia, with a height of 678.9 meters and the total story height of 118 story. It was considered the tallest building in Malaysia and among the tallest in the world, built near Stadium Merdeka to honor the Malaysian independent histories for the component inside it have premium office, luxury hotel, residential, intel, and observation. Basically, this component help to attract a lot of tourism to come to Malaysia. And the foundation and construction, it was built in 2014. They have acquired a high grade material and strict quality control to ensure that the stability of such a large building. Okay, for the project significant, the estimate investment is around 5 billion. It helped strengthen the Kuala Lumpur as a global business and tourism hub and able to support sustainable urban development. And last but not least, it was truly this type of building is truly excellent for to be used as a case study of deep foundation in Subatol construction.
Thank you, Syahmi. So, my name is Muhammad Faris bin Rul Hisam. I will present the case study of Jabatan Bukit Tuku, Bantu Hampa, a bridge replacement project located in Pasimas, Kelantan. This project was initiated by Malaysian government through JKR to replace the existing bridge and improve safety, reliability, and route connectivity. For local communities, it is part of the government's effort to upgrade transportation infrastructure in rural areas. The scope of the project include demolition of the old bridge, construction of a new bridge, foundation works, earthworks, drainage improvement, pavement construction, road upgrading, and utility relocation. This will ensure a complete and durable infrastructure system. Because the site has challenging soil condition, a deep foundation system is required. The structural load from the bridge are transferred safely to stronger soil or rock layer using deep pipe. Therefore, proper geotechnical investigation, foundation design, and strict quality control are very important during construction. The project brings many benefits. It improves transportation access for residents in Pasimas, reduce travel disruptions, enhance road safety, and support local economic activities. It also shows how modern construction technology and deep foundation system are essential in bridge engineering. So I will briefly present the parties involved in two major projects, Merdeka 118 and Jabatan Bukit Tuku. For Merdeka 118, the client is PNB Merdeka Ventures Sedia Merhad. The civil and structural work are LED by consultants such as Leslie E. Robertson Associates, Robert Work Group, Europe, and Jurundi Sedia Merhad. Mechanical and electrical engineering is handled by Vale and Associated and KTA Tenaga. The quantity surveyor is JUBN Sedia Merhad, while the main contractor is Samsung CNT Corporation in joint venture with UiTM Construction. The project is managed by Turner International Malaysia. For Jambatan Bukit Duku, the client is JKR Malaysia and JKR Kelantan. The project involves JKR Internal Division as a consultant for civil, structural M&E and quantity surveying. The contractor is Azmi Trendy and project management is under JKR Project Engineers and Superintendent Officer. In conclusion, both project involves coordinated collaboration between government bodies, consultant and contractor to ensure successful delivery.
Okay, thank you, Farid, for your detailed and comprehensive explanation of the project background for the ongoing project. Now, let us move on to the case studies section, and we will begin it by talking in much more detail about the complete project for the Merdeka 118. Okay, for this one, let us begin by talking about the type of pile used for the project. Merdeka 118 used a pile rough foundation with 136 large diameter bore pile, which means the building is supported by both a thick concrete rough and many bore pile. The rough spread the building load evenly, while the pile transfer the load deep into strong rock. Besides that, the diameter of the pile is 2.2 and 2.4 meter. The piles are very large because Merdeka 118 is one of the tallest buildings in the world. Large piles can support much heavier load compared to normal building pile. Besides that, the depth of the pile is around 52 to 60 meters. The pile extend deep underground until they reach strong bedrock. This ensures the building remains stable and prevent excessive settlement. You may be wondering, why bore pile? Bore pile was selected because they create less vibration and noise than driven pile. This is very important because Merdeka 118 is located close to Stadium Merdeka and Stadium Negara, where excessive vibration could damage nearby structure. Okay, now let's move on to the next point, and that is design consideration. Okay, for this one, it has small factor to represent it. The first one was to support extremely heavy load. The foundation must carry the weight of a 679-meter tall building, so it needs a very high load bearing capacity like bore pile. Secondly, do detailed site investigation. Engineer carry out soil investigation before construction to understand the ground condition and determine the best foundation design. Thirdly, different pile length. Since the rock level is different across the site, not every pile has same length. Each pile was designed according to the local ground condition. For the fourth point, wind resistance. For this one, strong wind create a large horizontal force on tall building. Therefore, the foundation was designed to resist this wind force and prevent overturning from happening. Last but not least, pilot testing. For this one, before finalizing the design, engineer tested several piles. The test result helped improve the final foundation design. Okay, now let us move on to the construction method and justifications. For the construction process, the bore piling process start by drilling a deep hole a deep hole. After that, a reinforcement cage is installed before concrete is poured using the trimming method. For the temporary casing, a steel casing is installed at the top of the borehole to stop the surrounding soil from collapsing during drilling. Okay, moving on to the next construction method and the justification for trimming concreting. Concrete is poured from the bottom of the hole using a training pipe. This prevent the concrete from mixing with the groundwater or drilling slurry and ensure about a better concrete qualities. Okay, now let us move on to the material used in this project. For the first material is high strength concrete. Concrete carry the heavy compressive load from the building and provide a long-term durability. Okay, moving on to the second point, and that is high reinforcement steel. Steel reinforcement strengthen the pile by resisting tension, bending, and shear force. Okay, moving on to the third material used, and that is temporary steel casing. The casing prevent the borehole from collapsing during drilling and help maintain the correct pile shape. For the fourth material is bentonite or polymer slurry. This drilling fluid keep the borehole stable before concrete is poured. Last but not least, the most important point in order to ensure that the material used is in a top form is none other than to do quality control. For this one, all material was tested to ensure that they met the required strength and durability standard for this project. Okay, now let's talk about the equipment and machinery used for the deep foundation for this project. Okay, for the first machinery used is rotary drilling rig. This machine drill the deep and large diameter hole required for the bore pile. Second machinery used is crawler crane. For this one, the crane lift heavy reinforcement cage and temporary casing safely into the borehole. Continue on with concrete pump and framing pile. These are used to place concrete continuously from the bottom of the borehole, and of course, last but not least, surveying equipment. Doing a surveyor instrument is important in order to ensure every part is installed at the correct position and remain vertical. Okay, let's move on to testing. Used to determine usability of the board pile used for this project. The first test is static load test. This test checks whether the pile can safely carry the required structural load. For the second test is dynamic load test. This is a faster alternative to static load test and is suitable for a very large pile. For the third test is cross-hole sonic logging, or for short CSL. The CSL detect hidden defect inside the concrete pile using ultrasonic wave. Now, last but not least, pile integrity test (PIT). Check whether the pile have a crack or construction defect after installations. Okay, that is all for me. I will now pass the baton to Uzai to continue with this presentation. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Uzai. So I'm going to continue about the effectiveness of bulk pile method used in Merdeka 118. Merdeka 118 uses a deep board pile foundation system to support its massive structural roots and overcome Kuala Lumpur's challenging karstic limestone geology. Large diameter board piles transfer the building load safely to strong limestone bedrock, providing higher load bearing capacity and minimizing settlement. The rotary Kelly drilling method also produces less noise and vibration than driven piles, making it suitable for urban construction. Overall, the board pile system ensures long-term structural stability, safety, and durability. And for the cost involved, the deep foundation walls are among the most expensive part of the Merdeka 118 project due to its height, complex ground condition, and specialized construction methods. Although the total project cost is around 5 billion, the exact foundation cost has not been disclosed. The high cost is mainly due to construction of over 1,000 large diameter board piles, intensive geotechnical investigation in karstic limestone, use of specialized equipment such as rotary kiln drilling rigs, polymer drilling flutes, trimming concrete, and heavy cranes. Comprehensive quality testing include load test and pipe integrity to ensure that the safety and performance of the foundation.
So, this is Jabatan Bukit Tuku Batu Hampar project in Pasir Mas, Kelantan, which is ongoing project for our case study. For next, I will explain detail about how strong foundation are making on this project for long-term infrastructure durability. First, the type of pile used in this project is large diameter bore cast in situ reinforced concrete pile with a diameter of about 1,200 mm. Each pile is designed to carry a working load of around 6,500 kN. In total, 30 pile were installed at abutment A and 41 pile at abutment B. These piles are made using high strength concrete grade C3240 and reinforced steel. One important feature is that sonic logging tubes are included, which allow engineers to check the quality of the concrete inside the pile after construction. These piles were selected because they are very suitable for heavy bridge loads and with soil condition, especially in river areas. They also produce low vibration and noise, which is important to protect surrounding structure and the environment. Next, in the design consideration, the piles are designed to resist different types of load, including dead load, traffic load, wind load, and also flood or hydraulic force. Since this is a bridge over a river, flood effect and score are very important factors. The pipe help transfer all structural loads down to stronger soil or rock layer. Engineers also carefully design the number of pile based on how the load is distribute. The main aim is to reduce settlement, avoid uneven movement, and ensure long-term stability of the bridge. Finally, the the construction method involves several steps. First, the site is prepared and pipe positions are set up. Then temporary steel casing is installed to support the borehole. A rotary drilling rig is used to drill the soil, followed by cleaning the borehole. After that, reinforcement cage and sonic lodging tubes are installed. Finally, concrete is poured using the trimming method ensure the ensure the concrete is placed properly underwater or in wet condition without segregation. The reason both piles are used is because they provide high load bearing capacity, low vibrations, suitable for river construction, adjustable depth based on soil condition and long-term durability. This is ensure the bridge foundation is strong, safe, and durable for long-term service. So I will continue with section 5. First, for material use, the main material is C3240 concrete, which provide high compressive strength and long-term durability. This is important because the pipe must support very heavy bridge loads. In addition, high-yield reinforcement steel is used to resist tension and bending forces. Inside the piles, temporary steel casing is also used during drilling to stabilize the borehole and prevent collapse. Furthermore, sonic lodging tubes are installed inside the piles to allow quality inspection after concreting. Overall, this material ensures structural strength, corrosion resistance, and long service life of the foundation system. Next, for equipment and machinery, several specialized machines are required. A rotary drilling rig is used to drill boreholes with a diameter of around 1,200 millimeters. A crawler crane is used to lift and install reinforcement cage and steel casing. A concrete pump with trimming-pipe system is used to place concrete continuously without segregation, especially under wet or underwater condition. A transit mixer truck supplies fresh concrete to the site. In addition, surveying equipment is used to ensure correct pipe position and vertical alignment, while CSL testing equipment is used for quality inspection of complete pipes. Finally, for testing and quality control, several important tests are carried out. The cross-hole sonic lodging or CSL test is used to detect internal defect inside the pipes. Static load test is used to check the load carrying capacity and settlement behavior of the pile. During construction, borehole inspection is also done to check depth, diameter, and verticality. Concrete quality is verified using slump test and compressive strength test. Reinforcement is also inspected before completing, and all drilling records are reviewed carefully. In conclusion, the combination of high quality materials, specialized equipment, and strict testing ensure that the foundation system is safe, strong, and able to perform well for long-term bridge stability.
So moving to the other slide, which is a problem involved at this project, which the bridge replacement project faces several challenges during construction. Maintaining traffic flow is difficult because the bridge is located on an active public road, requiring temporary diversion that may inconvenience road users. Kelantan's heavy rainfall and seasonal flooding can also delay excavation, foundation works, and concrete placement while increasing safety risks. In addition, weak soil conditions near the river may require deeper foundation, leading to higher construction costs and longer construction period. So, for the solution, this challenge can be addressed through effective planning and management. A traffic management plan (TMP) should be implemented to reduce traffic disruption by providing temporary diversion, warning signs, and scheduling major works during off-peak hours. Weather-related delays can be minimized through proper scheduling. Continuous weather delays can be minimized through continuous weather monitoring and temporary drainage or protective covering during concrete works. Detailed geotechnical investigation should be carried out to determine suitable foundation design and reduce ground-related issues. In addition, strict occupational safety and health (OSH) procedure, regular safety briefing, appropriate PPE, and continuous supervision can help and to ensure safe construction activities. And for the recommendation for this project, adapting modern construction methods such as precast or modular bridge component is recommended to reduce the construction time, improve quality, and minimize traffic disruption. The use of building information modeling (BIM) can also enhance project planning, coordination, and progress monitoring. After completion, regular inspection and maintenance should be carried out to extend the bridge's performance and long-term maintenance costs.
Topi, topi, topi. Dia ambil gambar topi.
So for the following slide, which is a problem involves solutions and recommendation for this project. For the problems involved, the main challenge in constructing the deep foundation for Merdeka 118 was the such karstic limestone geology, which contains irregular rock information and underground cavities. This condition made it difficult to determine the correct pile depth and increase construction risk. In addition, deep drilling required specialist equipment and skilled worker, while boreholes had to be stabilized using polymer drilling fluid to prevent collapse. Strict quality control was also essential during reinforcement installation and concrete pouring to ensure the strength and safety of the boat piles. And for the solution is to address this challenge, engineers carry out detailed geotechnical investigation to locate competent limestone and underground cavities before construction. Bevel rotary Kelly drilling rigs and polymer drilling fluid were used to ensure safe and accurate boat pile installation. Continuous semi-concrete pouring improved pile quality, while pile integrity tests, load tests, and continuous monitoring were conducted to verify that the foundation met the required safety and structural performance standards. And for recommendation for the future super building projects, the more detailed 3D geological modeling and additional site investigation should be carried out to better understand subsurface conditions. Integrating building information modeling (BIM) with geotechnical data can improve coordination and reduce construction errors. Real-time monitoring systems should also be installed to detect settlement of structure. In addition, applying value engineering can optimize the depth and spacing to reduce construction costs while maintaining structural safety. So moving to the other slide, which is a problem involved at this project, which the bridge replacement project faces several challenges during construction. Maintaining traffic flow is difficult because the bridge is located on an active public road, requiring temporary diversion that may inconvenience road users. Kelantan's heavy rainfall and seasonal flooding can also delay excavation, foundation works, and concrete placement while increasing safety risks. In addition, weak soil conditions near the river may require deeper foundation, leading to higher construction costs and longer construction period. So, for the solution, this challenge can be addressed through effective planning and management. A traffic management plan (TMP) should be implemented to reduce traffic disruption by providing temporary diversion, warning signs, and scheduling major works during off-peak hours. Weather-related delays can be minimized through proper scheduling. Continuous weather delays can be minimized through continuous weather monitoring and temporary drainage or protective covering during concrete works. Detailed geotechnical investigation should be carried out to determine suitable foundation design and reduce ground-related issues. In addition, strict occupational safety and health (OSH) procedure, regular safety briefing, appropriate PPE, and continuous supervision can help and to ensure safe construction activities. And for the recommendation for this project, adapting modern construction methods such as precast or modular bridge component is recommended to reduce the construction time, improve quality, and minimize traffic disruption. The use of building information modeling (BIM) can also enhance project planning, coordination, and progress monitoring. After completion, regular inspection and maintenance should be carried out to extend the bridge's performance and long-term maintenance costs.
Now, I will explain the comparison between the Merdeka 118 Tower project and the Bukit Tuku Bridge project. First, let's look at the similarities and construction method. Both projects use the same ball pile foundation system because it is suitable for supporting heavy structural loads. They also follow the same construction sequence, starting with rotary drilling, followed by reinforcement cage installation, and finally trimming concreting. In addition, both projects use reinforced concrete and steel reinforcement together with heavy equipment such as rotary drilling rigs, cranes, and concrete pump. Strict quality control and testing were also carried out to ensure the strength and safety of the foundation. However, there are several differences. Merdeka 118 is a super tall building located in an urban area, so it required deeper and larger diameter ball pile to support extremely high structural loads. In contrast, the Bukit Tuku Bridge project was constructed in a river environment, where the construction had to consider groundwater, river condition, and traffic management. Overall, although both projects used the same ball pile construction, process, the implementation was adapted according to the project requirement and site consideration. Next, let's compare the performance and overall effectiveness of both projects. For Merdeka 118, the ball pile foundation provides a very high load-bearing capacity to support one of the tallest buildings in the world. It also ensures excellent structural stability, long-term durability, and high safety performance by reducing settlement and maintaining structural integrity. Similarly, the Bukit Tuku Bridge Foundation supports the bridge structure, traffic loads, and environmental force such as river flow and soil movement. The foundation is also designed for long-term durability and safe operation throughout its service life. Overall, both projects successfully achieved their objective. The ball pile foundation system proved to be reliable, durable, and suitable for different types of large-scale construction projects. These slides compare the most implication of both projects. The Merdeka 118 project required a much higher construction cost because of its large project scale, deeper bore pile, advanced machinery, and larger skilled workforce. In addition, construction in a busy urban area increased logistic, safety, and site management costs. On the other hand, the Bukit Tuku Bridge project had a lower overall foundation cost. However, additional expenses were required for river access, traffic diversion, environmental protection, and water management during construction. Both projects also invest significantly in quality control and testing to ensure the foundation met safety and performance requirements. In summary, project scale, site condition, and structural requirement were the main factor influencing construction costs. Finally, This slide summarizes the overall comparison between both projects. Although Merdeka 118 and Bukit Tuku Bridge are different types of structures, they share several similarities. Both projects use bore pile foundation, rotary drilling, reinforcement cage, installation, trimming concreting, and comprehensive quality control procedure to achieve safe and durable foundation. The main difference are the construction environment and structural requirement. Merdeka 118 was built in a dense urban area and designed to support extremely high structural loads, making it more technically challenging and more expensive. In contrast, the Bukit Tuku Bridge project focused on overcoming river condition, groundwater and traffic management while maintaining stable bridge foundation. Overall, this comparison demonstrates that bore pile foundations are highly reliable and adaptable. They can be successfully applied to different types of construction projects by adjusting the design and construction method according to project requirement.
In conclusion, the study shows that the foundation systems are very important in construction, especially for heavy structure and weak soil condition. Both Merdeka 118 and the Bukit Tuku Batu Hampa Bridge use bopile foundation to ensure strength and stability. From this assignment, we understand that proper design, good material, advanced method, and strict quality control are very important for safe construction. In addition, site investigation and testing help ensure the foundation can safely transfer loads and reduce settlement. Overall, deep foundation selec- selection depends on soil condition, design, requirement, and construction method. This study improves our understanding of how deep foundations support safe, durable, and sustainable infrastructure. That's all for our group. Thank you.